Chapter 1, Practice Problems number 4. We want to prove or disprove. Again, this upside down A means for all integers x. If x plus 1 is even, then x plus 5 is even. So I think the best way to start this is just plug some values in for x to see if they work. So if I put a 1 in for x, 1 plus 1 is 2, that's even. 1 plus 5 is 6, that's going to be even. You can put in a few more examples to prove that this is something that's going to be true. Okay, so the next thing we want to do is assume that the chosen variable x is in the domain. There, in other words, x is an integer, since we're talking about for all integers. And then we're going to assume the if part, if x plus 1 is even. So we're going to assume x plus 1 is even. Then what we have to go about doing is prove the then part. I'm going to establish what I call a dummy variable, just so that we can kind of use it within this problem. I'm going to let a be that variable. Then I'm going to say that x plus 1 is even, therefore that's going to equal 2 times some number, which I already established as a. And that's because of the definition of an even integer. Now we're going to find x plus 5. So we're going to take this x plus 1 and transform it into x plus 5. And I can do that by adding 4 to x plus 1 to get x plus 5. But if I do that on one side of the equation, I have to do it on the other side. So I have this 2a and I have to add 4 to it. So because we add one value to one side of the equation, we have to balance it out by adding it to the other side. So this 2a plus 4 is something that we have to transform into something that is an even integer. So I'm going to take this 2a plus 4 and factor it. And factorization is just basically the distributive property for multiplication. In this case, over addition. So I'm taking out the 2, I'm left with a plus 2 inside of parentheses. From there, I'm going to establish another dummy variable. I'm going to let z equal a plus 2. And I'm doing that to make this very clear that I have an even integer. When I replace z or a plus 2 with z, then I get 2z, and you can see that's kind of in the same form as this 2a at the top. We have 2 times some number. Because of the substitution property for equality, I can get that. And now I've shown by the definition of an even integer that x plus 5 is even when x plus 1 is even.